Okay, today I'm going to go over the cross-cutting concepts that we use that unite all the big ideas in science. So we're going to start with the first one, which is patterns. So this highlights that structures or events are often consistent and repeated. So the phases of the moon, it's consistent, it's repeated, we know what happens on a 28-day cycle. So it could be something like the phases of the moon or the shape and patterns we see within snowflakes. They're consistent, they're repeated within the snowflake. The next cross-cutting concept is cause and effect. So this is how different things are connected and identifies the reasons behind that connection. So a good example of this is the relationship between predators and prey. When you have a lot of prey, a lot of things to eat, the number of predators, the animals that eat them, goes up. But once they get too high and they eat all the food, that number of prey animals goes down, and then the predators goes down, and it just keeps happening that way. Additionally, cause and effect could be a ball rolling down a piece of wood hits a domino with cause and effect. That effect of hitting the domino causes the dominoes to knock down, and so on and so forth. The third cross-cutting concept is scale, proportion, and quantity. So this is different ways to look at the same object. So we might look at it up close, like looking at a feather up close is going to look different than if we looked at a feather further away. This smaller picture is the different scales of the universe. So our Earth, and then our solar system, and our local group, and our galaxy, and going from really small to very large. And this is how we understand nature differently based upon how we are looking at the different parts of it. Next is systems. So this is describing how things connect and interact. You're probably familiar with the water cycle or the circulatory system. We're talking about how these different pieces, so trees in the water cycle, streams in the water cycle, the sun, how those different pieces come together to make an entire system that functions. Next, we have energy and matter. Energy and matter change forms but are not created or destroyed. So you've learned this in freshman science. Energy flows and matter cycles throughout natural systems. So here we've got two examples of energy and matter. One is energy going through the ecosystem into plants, how the plants take the sunlight and turn that into their own energy. Animals can eat that and turn that into energy for them. We also have a star using energy, changing types of energy. Next, we have structure and function. How things are shaped and put together determines what they do. So I have some really good examples. We've got the different shape of the skull determines what they eat and how they eat. Shape of a bridge or a building determines how much load it can hold, or how wide of a space there can be under a bridge. The shape of the wing feathers determines what type of flying they do. Last, we have stability and change. In nature, some things stay the same and some things change. Changes can be fast or slow. So the rock cycle is how rocks change, sedimentary rock, metamorphic rock, igneous rock, how they change over time. That's a very slow process. Um, Things might stay the same or become different depending on a variety of factors. So we've also got an evolutionary tree. So these animals became different due to outside factors. Again, this is a very slow process.